Welcome to the Physical Science 20 lesson for completing the reaction. This goes along with the RM6&7 assignment. You will be given the reactants and you need to identify what type of reaction will occur and predict the products. The first reaction type we will look at are decomposition reactions. These are easily identified because there is only one reactant. There are three types of decomposition reactions that you will have to be familiar with. Ionic compounds will separate the cation from the anion. This is very common when ionic compounds are placed in water. If given NaCl, you will have to break it up into its positive and negative charges. So NaCl becomes Na plus Cl minus. Covalent molecules decompose into their element's simplest form. That's diatomic or lone element. Given phosphorus pentachloride, you would have to break it up into phosphorus and chlorine. Phosphorus is not a diatomic, so we just write P. Chlorine is a diatomic, so we write Cl2. In hydrated compounds, the salt will be separated from the water molecules. This is usually done through heating. If given copper 1 carbonate dihydrate, we have to separate the salt from the water. So in the end, we wind up with copper 1 carbonate plus 2 water molecules. Synthesis reactions. Two reactants become one product following one of two forms. The first form, a cation and an anion, will combine to form a neutrally charged ionic compound. Calcium is a +2 charge, hydroxide has a -1 charge, lowest common charge would be a 2, so I need 1 calcium to give me a +2, I need 2 hydroxides to give me a -2. That's easy. Tougher is the second form. A metal combines with a non-metal yielding an ionic compound after there's an exchange of electrons. The metal's charge is found on the periodic table. The non-metal's charge comes from the common negative ion list. Now we know aluminum takes a +3, that when chlorine takes a charge, it's a -1, so lowest common charge is 3, so I need 1 aluminum to give me a +3, I'll need 3 chlorides to give me a -3. You will not be given a metal with more than one charge option. Metals that have more than one charge could make several different products. In the questions that you've been given, there is only one plausible answer. You may notice that you are never given two nonmetals, because when it comes to synthesis reactions with two nonmetals, there are a number of different products that may form. So questions will not include the mixing of two nonmetals, since covalent molecules produce a number of combinations and determining the exact product is not possible. Single displacement reactions. These reactions will have a single species reacting with an ionic compound. The single species replaces either the cation or the anion in the ionic compound. Important! Not only should elements be balanced in the reaction, so should charges. This means if the species coming in has a charge, the single species leaving must also have a charge. Here magnesium is coming in with a +2 charge, and leaving is hydrogen ion, 2 of them, so that we have a +2 charge on either side of the equation. If the single species coming in does not have a charge, the species leaving cannot have a charge. Here magnesium this time does not have a charge. That means hydrogen has to leave without a charge. And note that hydrogen is a diatomic, so it cannot leave as just H, it is leaving as H2. Metals will replace the cation. Magnesium must take a positive charge, so it will form a compound with a negative chloride. Nonmetals will replace the anion. Chlorine is a non-metal. It will take a negative charge, so it will form a compound with a positive potassium. Double displacement reactions. We have two ionic compounds. Cations exchange anions, and the new formulas are written so the results have a neutral charge. This is exactly the same thing that you did in the RM6 assignment. Combustion reactions, we always have an organic reacting with oxygen, and the resulting products are always carbon dioxide and water. I would like for you to pause the video and copy the following onto your pink sheet. Example 1, silver nitrate plus potassium bromide. What type of reaction is this? Well, I've got silver nitrate, that's a positive and a negative, so that's a pair. I have potassium bromide. Again, that's a pair because I have a positive and a negative. So if it's a pair reacting with a pair, that is double displacement. So I'll write next to the equation, double displacement. Now let's complete that reaction. Silver is number 47 on the periodic table. It takes a +1 charge. So over top of silver, I will write Ag+. Nitrate is on my negative list, and that is NO3-. Lowest common charge is a 1, so I need 1 Ag to give me a +1 charge. I need 1 NO3 to give me a -1 charge. Potassium, number 19 on the periodic table, takes a +1 charge. So over top of potassium, I will write K+. And bromide, again, it's on our negative list. So I'll write Br- over top of bromide. Lowest common charge is 1, so I need 1 potassium to give me a +1. I need 1 bromide to give me a -1 charge. Now silver is going to go with bromide when we undergo the double displacement. That's a +1 -1, so I need 1 silver to give me a +1, 1 bromide to give me a -1 charge. Potassium is going to go with nitrate. Remember, we always write our positive first, our negative second. Lowest common charge is 1, so I need 1 potassium to give me a +1 charge. I need 1 nitrate to give me a -1 charge. You would balance the equation now, but it is already balanced, and we're good to move on to the second example. Example 2, calcium phosphate. What type of reaction is this? Well, we only have one reactant, so that has to be decomposition. So let's write decomposition after calcium phosphate. Now to complete the reaction, I look up calcium on the periodic number 20. It says it takes a +2 charge, so I'll write Ca2+ over calcium. And phosphate is on our negative list, that's PO4 3-. 2 and 3, lowest common charge is 6, so I will need 3 calciums to give me a +6, and to balance that off, I will need 2 phosphates to give me a -6. Now this is decomposition of an ionic, so that means it breaks up into its ions, its positive and negative charges. So when it breaks up, it's going to make Ca2+ and PO4 3-. Now we have to balance this out. I have 3 calciums on the left, so I will need 3 calciums on the right. I have 2, and I can treat them as a chunk. I've got 2 phosphates on the left, so I will need 2 phosphates on the right. Not only do our elements balance out, but so does our charge. We have no charge at all on the left-hand side. On the right-hand side, with 3 Ca2+, I have a +6 charge, and with 2 phosphates, I have a -6 charge. And a +6 and -6 come together to give you no overall charge on the right-hand side either. So elements and charges both balance. Example 3, silver plus sulfur. We have silver all by itself, we have sulfur all by itself, so that has to be synthesis. So write synthesis after silver sulfur. Silver is just Ag, and sulfur is just S. But it is a synthesis reaction, so we know the two are going to have to come together. So I will look up silver on the periodic table, and I see that when silver takes a charge, it takes a +1 charge. So over silver, I will write Ag+. I look up sulfur on the periodic table, and I see that it is a nonmetal. And when nonmetals take charges, they take negative charges. So that means I will have to look up sulfur on our negative list. So over top of sulfur, I will write S2-, as that is the charge that sulfur takes when it has a negative charge. So if these two are coming together, the lowest common charge will be 2. So in order to balance out, I will need 2 silvers to give me a +2 and 1 sulfur, which will give me a -2. Now I have to balance the equation out. I have 1 sulfur on either side, but I'm going to have to balance out the silvers. Since I have 2 on the right-hand side, I will need 2 on the left-hand side, and we're good to move on to example 4. So example 4, we've got methanol reacting with oxygen. Methanol, what is that? Well, we got to figure out what type of reaction this is. And I see we've got oxygen, which is O2, and it's reacting with methanol. And methanol is not on our periodic table. It's not listed as a negative ion. So, hey, it kind of looks like a combustion reaction potentially. So I'm going to label that as combustion. So let's write out that equation. To get the formula for methanol, and to get the formula for any of the organic molecules, we will have to reference the RM4 assignment. Methanol is CH4O, so we will write down CH4O, and that is reacting with oxygen. And when we look on our periodic table, we see that we highlighted oxygen because it is a diatomic. That means O can never be all by itself. We will have to write oxygen as O2. And being that this is a combustion reaction, it will produce carbon dioxide and water. Now we have to balance. I'll put a 1 in front of methanol, so I'll balance the carbons first. When I put a 1 with methanol, that gives me 1 carbon on the reactant side, so I need 1 carbon on the product side, so I will place a 1 in front of the CO2. Now we will balance out hydrogen. Putting a 1 with the methanol gave me 4 hydrogens. That means I will need 4 hydrogens on the product side. And to get 4 hydrogens, I will require 2 water molecules. Now to balance out oxygen. On the product side, 1 carbon dioxide molecule gives me 2 oxygen. 2 water molecules gives me 2 oxygen. So I have a total of 4 oxygen on the product side. So I will need 4 oxygen on the reactant side. 1 methanol molecule gives me 1 oxygen, so that means I still need 3 more oxygen atoms. And it turns out that nothing is going to work for me because no matter what I put in front of the O2, that will not give me 3 O's. So I will have to start again. I will put a 2 in front of the methanol, balance out carbon first. The 2 gives me 2 carbons. So that means I need 2 carbons on the product side. That means I will need 2 carbon dioxide molecules. Now I'll balance out hydrogen. Putting a 2 with the methanol gave me 8 hydrogen. So that means I need 8 hydrogen on the product side. So I will need 4 water molecules to get 8 hydrogens. Now to balance out oxygen. On the product side, 2 carbon dioxides gives me 4 oxygen. 4 water molecules gives me 4 oxygen. That's a total of 8 on the product side. So I need a total of 8 on the reactant side. 2 methanols gives me 2 oxygens already. So that means I still require 6 more oxygen atoms. And I can get that if I place a 3 in front of the O2. Now, our reaction is balanced. We're good to move on to the next example. Example 5, we have barium nitrate reacting with phosphate. So what kind of reaction is that? Well, we've got barium and nitrate together, phosphate by itself, so that has to be single displacement. So write single displacement after barium nitrate plus phosphate. I'm going to start by looking at barium on the periodic table. Number 56 takes a +2 charge, so over top of barium I'll write Ba2+. Nitrate is on my negative list, so over nitrate I will write NO3-. That's a +2 and a -1 coming together. Lowest common charge is 2. So I will need 1 barium to give me a +2, 2 nitrates to give me a -2. I'll look up phosphate, and it is also on my negative list. So over phosphate, I will write PO4 3-. So barium nitrate is reacting with phosphate. Phosphate has a negative charge. So in a single displacement reaction, a negative will want to go with a positive. So phosphate and barium will be coming together. With a +2 charge and a -3 charge, the lowest common charge is 6. So when they come together, I will need 3 bariums and 2 phosphates. 3 bariums gives me a +6, 2 phosphates gives me a -6. And the nitrate will be leaving by itself. Now to balance. I'll put a 1 in front of the most complex formula, which is barium phosphate. I will balance out the bariums. When I place a 1 in front of the barium phosphate, that gives me 3 bariums, so I will need 3 bariums on the left-hand side. I will balance out the phosphates as a chunk. When I put a 1 in front of the barium phosphate, that gave me 2 phosphates, so I will place a 2 in front of the phosphates on the reactant side. I will also balance the nitrates as a chunk. I have a total of 6 nitrates in the barium nitrate. So that means I need 6 nitrates on the product side. So I will place a 6 in front of the NO3-. Now everything balances out, and that includes charge. On the reactant side, with 2 phosphates, I have a -6 charge. On the product side, with 6 nitrates, I also have a -6 charge. Now before I move on, I need to erase any ones that were used to balance the equation. And now I'm good to move on to the next example. Example 6, carbon monoxide. Well, that's the only thing there, so that has to be decomposition. So carbon and oxygen are both nonmetals. So that means we have a covalent molecule, and we're using covalent naming. So we will need the covalent naming chart. The only thing we see there is mono. And of course, mono is never listed on the first element listed. So we have 1 carbon there, and we have 1 oxygen. So CO. And that is breaking up into, well, if this is a covalent molecule, it breaks up into its simplest form, which are single elements or diatomics. So carbon is just a single element. So CO is going to break up into C, and oxygen is a diatomic. So CO is going to break up into C and O2. To balance, I have 2 oxygens on the product side, so I will need 2 oxygens on the reactant side. I now have 2 carbons on the reactant side, so I will need 2 carbons on the product side, and we're good to move on. Example 7, we have barium hydroxide heptahydrate. That is only one formula. It's a big formula, but it's only one formula. So what type of reaction is it? It has to be decomposition. So we'll write decomposition after the barium hydroxide heptahydrate. We'll look up barium on the periodic table. Barium takes a +2. Hydroxide is on our negative list. It is OH-. When they come together, lowest common charge is 2. So that's Ba bracket OH bracket 2, giving us a +2 -2. And now we have to deal with that heptahydrate. On our formula sheet, we have this little box that says, in the name of the ionic compound is followed by a covalent prefix identifying the number of water molecules followed by the word hydrate. So we have hepta and hydrate. Hepta, a covalent prefix, means 7. So I have 7 waters. And it says when we write the formula, a dot is placed between the ionic formula and the number of waters coordinated around the salt. So I will write after the Ba bracket OH bracket 2, 7H2O. And this is decomposition. And in the notes we said if it's a hydrated compound, the water gets separated from the salt. So barium hydroxide is by itself, and we've separated the 7 water molecules. So instead of having a dot, we will have plus 7H2O. Example 8, iron 2 sulfate plus aluminum. What type of reaction is this? I have iron 2 sulfate, which is a pairing, and aluminum is all by itself. So that means it has to be single displacement. We'll start with iron 2. I look up iron on the periodic table. It says it can be a 2 or a 3. And we know it's taking the plus 2 charge because it was identified in the name. Remember, a Roman numeral is the charge. So iron has a plus 2 charge. Sulfate is on our negative list. So I will write SO4 2 minus over sulfate. When they come together, plus 2 minus 2, lowest common charge is 2. So I just need a 1 of each. And that is reacting with, and it just says aluminum, so Al. Now this is single displacement, so that means the aluminum is either going to go with iron 2 or with sulfate. To determine who aluminum is going to go with, I have to look it up on the periodic table. And I see that aluminum is a metal, and it takes a plus 3 charge when it takes a charge. So that means positive always goes with negative. The aluminum will be going with the sulfate. Lowest common charge is 6. Positives are always written first. So to get a plus 6 charge, I would need 2 aluminums. And to get a minus 6 charge, I would need 3 sulfates. Leaving all by itself is the iron. And since aluminum came in with no charge, iron has to leave with no charge. If it were to leave as Fe2+, that would mean there's a charge on the product side when there's no charge on the reactant side, and our equation could not possibly ever balance. So let's balance out this equation. I've got 2 aluminums on the right-hand side, so I will need 2 aluminums on the left-hand side. I've got 3 sulfates on the product side. I will need 3 sulfates on the reactant side. And when I place that 3 there, that gives me 3 irons on the reactant side. I will need then 3 irons on the product side. Our equation is now balanced, and we are good to move on. And there you go, that's the end of the lesson. Good to start working on that RM6 and 7 assignment.